Hi everyone, in this video we're going to go through the Maths Methods trial exam for exam 1. This exam is only 1 hour long, but you get 15 minutes reading time. In this reading time you should be really looking at which questions you're going to be confident with. So, it's quite a short exam, but it will go quickly and you probably won't finish it all in the given time. So I would strongly encourage you to look at the questions and think, okay, question 1, it's a differentiation question, which you would expect in your VCAR exam. Usually they start off with a calculus-based question, so usually finding the derivative or antiderivative, and it's quite a simple one. So for this one here, you're using the quotient rule. So in your reading time, obviously you can look at the formula sheet. So you might want to look at the formula sheet, just say, okay, I'm going to be ready. I know where the quotient rule is. So, oops, that's not what I wanted. I wanted this one here. So your product rule, quotient rule, and chain rule are all on your formula sheet, as well as some simple derivatives and some simple antiderivatives, but you still need to be able to do them, obviously. All right, let's go back to the exam. Okay, so then we've got some exact values. So you might think, okay, I know my exact values. Sorry, that's a derivative, but it looks like we're going to have to use our exact values for it. Obviously, you can't write in reading time, but you might think, okay, well, I'm going to have to write that down. So you might start thinking about, okay, how do I remember the exact values? Then some more calculus. Okay, and then we move on to probability. Now, probability was our most recent topic. You might be thinking, oh, yep, I'm really confident with that. So you might do some, start with this probability, or you might do part of it. What have we got there? We're solving a cos equation, a trig equation. So just going through your graphing. So when you're graphing, I think you should be very happy if you have to do some graphing, because often they're worth more than 1 mark. So 2 marks, or in this case 3 marks. And as long as you show all the features, it should be an easy 3 marks for you. All right, let's move on. We've got another probability-based question. What is that worth? That's 3 marks. So just doing as much as you can, even if you can't get it all done. Then we've got a composite function question. And then question C, it's worth 3 marks. Now I'm looking at that and I'm thinking, all right, kind of feel I know what they're expecting there. Okay, but I won't know until I'm actually doing it. But we've done questions like this before where you have to treat it as a quadratic. So in my head, I'd be like, oh, okay, I know how to do composite functions. Done quite a few of them on past exams. That should be okay. Then we've got a log. So just solving a log equation. The bases are the same, so no change of base required. So just understanding the log laws. It's also worth 3 marks. So if you're good with your logs, you might want to start with that. Then there's a derivative question. And then when I say hence find, so you're going to have to use integration by recognition. Now we did this towards the end of the term after we finished probability. We did it in one lesson and there's also a video on it. So integration by recognition always pops up. So it's a good idea to practice a few questions like that. What have we got here? So we've got a function, show that its derivative is that. Okay, that looks all right. Then we're finding the area. So we've done quite a few questions like that. Or tangent. Tangents can always be tricky. And I just did a past VCAR question with the tangent and it was quite difficult. And it's also worth 4 marks. Now you shouldn't be saying, oh, 4 marks, or this one's 3 marks and this one's 4 marks. I should really do these first. You're better off spending your time on questions that are easier and worth fewer marks. Okay, because you could be spending a long time on these questions and not get far at all. All right, so we're at the end. So let's go, I'm going to do it in order just because, you know, why not? But if I was doing this actual exam, I probably wouldn't do it in order. All right, so for question 1, so as I said before, it's a quotient rule question. So your quotient rule is here on your formula sheet. So whenever you're doing some practice exams or trial exams, you should be using your formula sheet at the same time. All right, so I'm looking at that and I need to identify U and V. So obviously U being on the numerator, V is on the denominator. Now, with all the product rule, chain rule, and quotient rule, the quotient rule is the one I always forget, so I'll probably have to refer back to the formula sheet in time. All right, so U is equal to 2x minus 1, so du dx is equal to 2, and then we're going to let V equal the denominator, which is x plus 3, so dv dx is equal to 1. All right, so that's all the information you need. And then we're just substituting it into the chain rule. So if I get my formula sheet, so many tabs open. So V times du dx minus u times dv dx over v squared. So I'm just going to take one last snapshot. All right, so V is x plus 3. And put that in brackets because we've got 2 terms. Oh gosh, didn't mean to do that. 2 terms there. And then we're going to multiply that by du dx, so times 2. And then the next one was minus, wasn't it? Oh gosh, I'm terrible with my memory. Minus u. U is 2x minus 1. Oh, I don't like using PDFs. Times dv dx, which is 1 all over v squared. So v is x plus 3. And we have to square that. All right, let's just tidy it up a little bit. So 2 times x plus 3 minus 2x minus 1 over x plus 3 squared. Now, don't go ahead and cancel these out. You can't cancel them because you've got multiple terms on your numerator, so don't make an error like that. You can expand this, so I might go ahead and do that. So 2 times x, I would say on an exam that this is fine as your final answer, but I'm going to expand it anyway. 2x plus 6 minus 2x. And then we've got a negative and a negative, so plus 1 over, and you could expand that if you want. I'm not going to. I think it's just better to leave it in simplified form. So 2x minus 2x goes, and then x plus 1 is 7. So probably should have simplified that. Thinking now. So 7 over x plus 3 squared. I'm just checking my answers as we go. So the feedback from the assessor was that many didn't recognise they should use the quotient rule. And that's very disappointing. Whenever you see finding the derivative, if it's not like a straightforward one, you're either using the chain rule, the quotient rule, or the product rule. Okay, so you need to be familiar with those 3. All right, question B. So in question B, we've got to find the derivative. So they're given us the function and they're asking for f dash. So we've got to find the derivative of this function first. So f dash x. All right, so the derivative of sine should be on your formula sheet. So you can see here, the derivative of sine ax is a cos ax. Let's just go back. Okay, so we're going to keep that half there times, and that 4 comes out, 4 cos. And then 4x. So a half times 4 is 2. So 2 cos 4x is your derivative. And then we've got to find f dash of pi on 16. So it's just substituting that in. So 4 times pi on 16 gives us 2 cos pi on 4. And we're just, got to know our exact values. So cos pi on 4. All right, with your exact values, I'm not going to go through them here, but you need to memorize them off by heart. So pi on 4 is root 2 on 2. And the reason I know that is because, and it's probably the only one I really always remember, is because cos pi on 4 and sine pi on 4 are both root 2 on 2. So those 2's cancel out and we're left with root 2. Okay, so please remember your exact values. All right, moving on to question number 2. So find an antiderivative of square root of 3x plus 1. So we can write our integral, and I'm going to, just to save us time, I'm going to write that with power of a half, and don't forget dx. You need to have dx on there. All right, so we're just finding an antiderivative, so it's not a definite integral. So, and we also don't have to put plus c. You can put plus c because it is also an antiderivative, but you don't have to. If it said the antiderivative, you do have to put plus c. All right, so we're going to keep 3x plus 1, and we increase our power by 1, so it becomes 3 on 2, and then we divide that by 3 on 2 times 3. Now, I don't think something like this is on your formula sheet. Let's just have a quick look. No. Oh, actually, there it is. Second one down. Okay, so it is on your formula sheet, which is good. So just being familiar with that. All right, especially, I keep thinking it's a Word document, especially when you're doing past exam papers. All right, let's just tidy this up a little bit because it's a little bit messy. All right, so what can I do? So that power of, okay, so I kind of think leaving it as to the power of 3 on 2 is fine because it's only worth 1 mark, but we do need to tidy up this denominator. You can't leave a fraction in a denominator. So this is the same as dividing by 3 on 2 times 3, so 9 on 2. So when we're doing that, we can multiply by the reciprocal, so 2 on 9. So we can write 2 times 3x plus 1 to the power of 3 on 2 over 9. Now, you can also write this, if you like, by simplifying this power. So if you've got something, and I'll just do it to the side here, something to the power of 3 on 2, you can separate your powers. So you've got a unit fraction and then an integer. So a to the power of a half is the square root. So a square root of a, and then you can put the cubed on the outside. So for this one here, we can have 2/9 times the square root of 3x plus 1 cubed. Actually, I probably should have put that over there. All right, but leaving it as this is fine. All right, moving on to question B. Given that, so we've got a definite integral equals log EP, so we've got to find P. All right, so let's find the definite integral. So we can take that 2 out if we want to, and I'm going to 1 on x minus 1. Don't forget your dx. I'm not going to worry too much about equals log EP just yet. I'm just going to focus on the left-hand side. So the antiderivative of 1 over x minus 1 is log base E x minus 1. And don't forget the 2 out the front, and then we've got the 5 and the 3 here. So we just need to substitute in the 5 and the 3. All right, I'm going to do that just in one step. So 5 minus 1 is 4. Don't forget to put brackets around your argument. And then we've got log E of 3 minus 1, which is 2. Oh, starting to do square brackets. All right, because we've got the same base in here, I can, because we're subtracting using your log laws, it's 4 over 2, and that equals 2 log E2. Please keep putting brackets around it, so P is equal to 2. Oops, no it's not, my bad. Went a step too far. Let's just get rid of that first, which is equal to, now that 2 using your log laws can go there. So we've got log E2 squared. So that means, well, we know what 2 squared is, which is 4, and P is equal to 4. All right, so I just forgot that last little bit there. So that was worth 2 marks, probably getting the definite integral and then finding P for that one. All right, not a bad question. Question 3. So now we've got some probability. So let X be a normally distributed random variable with mean 15 and variance 9. Let Z be a random variable with a standard normal distribution. Find the probability that X is less than 15. All right, when you think of the normal distribution, or wherever you see a question that has a normal distribution, I always think it's good to visually see what you're doing. So this has a mean of 15. And it has a standard deviation. So your standard deviation, actually I might write that above because we might need space. All right, your standard deviation is just the square root of your variance, so the square root of 9, which is 3. So we might need that later. But we want to know the probability that X is less than 15. So if your mean in a normal distribution, the mean in a normal distribution splits it in half. It will always be a half. So less than 15 is this section here, and it's just equal to a half. All right, find K such that the probability that X is greater than 9 is equal to probability that Z is less than K. All right, I'm going to draw my normal distribution again. Probably not the best normal. I'm going to do that again. That's an embarrassing normal distribution. All right, that's a bit better. Okay, so 15 goes in the middle. And remember our standard deviation is 3. So I'm going to go down. So 15 minus 3 is 12. Then we've got 9. And then we're going to have 6. And you could keep going, but usually 3 is enough. And on the other side, we've got 18, 21, and 24. So we're doing X is greater than 9. So we want this, that area, and it's equal to the probability that Z is less than K. So this area, and it's a shame I can't, I don't have a different color. I can only use red on PDFs. I'm sure there's a way to change it. All right, if I did the the standard normal, we have a mean of 0. So and a standard deviation of 1, obviously, that's what I'm doing. Okay, so they actually line up. All right, so if we're looking at Z is less than K, because your normal curve is symmetrical, it's the same as, well, I'm 2 standard deviations from this end, so it's going to be the same as 2 standard deviations from the other end. So those 2 areas are actually the same. All right, they're equal. It's just, on opposite ends. So K is equal to 2. All right, moving along to question 4, and I'm just going to turn the page on my notes here. All right, so here we've got a cos equation that we need to solve. So we've got 2 cos pi x on 3 equals 1, and we've got x is between -2 and 4. All right, so I'm just going to write this pi x on 3, and dividing both sides by 2 will get rid of that 2 there, so equals 1/2. And then we've got pi x on 3 equals inverse cos of 1/2. All right, so knowing your exact values, we're going to have pi on 3. Now we are solving for x, and we do have to consider our domain. So at this point, we're in between, just making sure I've got the right sign there. All right, so x is between -2 and 4. Now, because we're solving for pi x on 3, I'm going to change this here. And we did do similar ones in class, but not like this. So I think we just did from 2 pi, or solving for 2x, not pi on 3. Okay, so if you're changing the x to pi on 3 times x, then you've got to multiply both the other two sides by pi on 3 as well. So instead of having -2 on the left-hand side, we're going to have -2 times pi on 3. Okay, because I multiplied the x by pi on 3, and then we're going to do the same on the other side. So I do just need to simplify them. So we're going to have -2 pi on 3. Now, doing it this way does help you get the correct solutions. You're in the correct domain. All right, so with our unit circle, we have a positive, so it's 1/2. So we're in the first quadrant. So all stations to Caulfield. There we go, the first and the fourth quadrant. So we're going to be going this way, 0 plus, and then our, then we're going to pi, and then 2 pi. All right, so we've got pi x on 3 is equal to 0 plus pi on 3, and 2 pi minus pi on 3. Now I'm just going to tidy that second one up a little bit, or maybe both of them. So 2 pi is 6 pi on 3, so 6 pi on 3 minus pi on 3 is 5 pi on 3. Okay, and we do have to solve for x, so if I just scroll down a little bit more. To get rid of the pi on 3, we do need to just multiply by its reciprocal, so 3 on pi. All right, so they will cancel out. So we're going to do the same for the first one, times 3 on pi, and then 5 pi on 3 times 3 on pi. So that's going to be 1, and then we're going to have, they're going to cancel out. All right, I'm going to actually show you, and I've made an error because, and I've picked it up. So if you're in your exam, this is probably good that I made this error, because your domain is from -2 to 4, and I've just gone ahead and treated the domain just the positive. I didn't go backwards as well. So obviously we can't have that 5. So if I did that on the exam, I would just cross that out. But I should have included 0, so up here, 0 minus pi on 3. So if I just do that one maybe over the side, so negative pi on 3. And remember that we multiplied everything by 3 on pi. So that gives you -1. So our two solutions are x equals 1 and x equals -1. All right, and you can see I probably shouldn't have gone around all the way to 2 pi, but that's okay. I realized at the end that I'd gone too far. All right, question B. So we've got a trig function. Take note of your domain. So we're going from -2 to 4. Remember, this is your amplitude. This means it's being translated down 1, and the pi on 3 is not your period, but it does help us get our period. Okay, so label all points of intersection with the axes and endpoints. Okay, so we're going to have to sketch this function. So we have an amplitude of 2. It's shifted down 1 unit. And our period is 2 pi on n, where n is pi on 3. So 2 pi times 3 on pi, so they cancel. So you've got a period of 6. All right, I'm just going to make this a bit, oh, not that small. All right, so in the previous question, we found what we were finding. What were we finding? Hold on, a little bit blank. Our x-intercept, sorry. There we go. -1 and 1. Now we have shifted down 1 unit. So we usually use our x-axis as the halfway point, but because we've shifted down 1, I'm just going to sketch along here to show that that's going to be the halfway point. So we're kind of cutting our trig graph in half. All right, our amplitude is 2, so we're going up to either side of that dotted line. So our maximum is going to be at 1, so I'm going to draw another dotted line there. And our minimum is going to be at -3. All right, so that just helps you sketch, and there's nothing wrong with drawing dotted lines, or if you should be using a pencil anyway, so doing faint lines. All right, the cos graph hasn't hasn't translated left or right, so you still start your cos graph here at 0, 1. All right, so we're going here. Now you've got a period of 6, but take note that our graph finishes at, or our endpoints are -2 to 4. So when you are sketching your graph, you can't go just because they've given you, I guess, extra space, you've got to take note of that domain. So at -2, we're at here at -2, -2. So you can get those values just by substituting it into your equation. And we've got another turning point here. And then we're going to go up to 4, -2. Now it does say label all points of intersection with the axes and endpoints with their coordinates. All right, so even though we've I've drawn a pretty good graph, we're not going to get the 3 marks unless I label the coordinates. So this coordinate here, remember you do your x first, so 4, -1. Coordinates of this axis intercept, 1, 0. This axis intercept, 0, 1. This one here, -1, 0. And then down here we've got -2, -2. Okay. All right, moving along. So now we've got another probability question. So every morning a student drinks tea or coffee. If she drinks tea on one morning, the probability that she drinks tea the next morning is 4/5. If she drinks coffee on the one morning, the probability that she drinks tea the next morning is 2/5. If the student drinks coffee on one morning, what is the probability that she drinks tea on exactly 2 of the following mornings? So you can have student drinks coffee one morning, so she can have coffee, drinks tea on exactly 2 of the next 3. Okay, so there's different combinations you can have. So you can have tea, tea, coffee. You can go tea, coffee, tea, or coffee, tea, tea. Now, this is, these are not independent, okay? So they're not independent because what she drinks one day depends on whether she drank coffee or tea the previous day. Now, we know she starts with a coffee. So the probability of all of these, the first one basically comes from the coffee. You can draw a tree diagram for this, very time consuming. But let's just do the probability of each one so you can see. So probability of tea, coffee. So remember, she drank coffee on the first day. So if she drinks tea on one morning, the probability that she drinks tea the next one, drinks coffee on one morning, the probability that she drinks tea the next morning is 2/5. So we're going to have 2/5 here. All right, so coffee, then tea. So she definitely drinks coffee and then tea. Then if she's had tea, it's 4/5. And then obviously, if she's not drinking tea, she's drinking coffee. And I don't like that arrow there, but I'm talking you through it so you would know. All right, so when you're multiplying fractions, you multiply the numerators. So 2 times 4 times 1 is 8, and 5 times 5 times 5 is 125. Do not simplify, even if you can't really simplify that one. All right, TCT. So again, we're starting with T, so it's going to be 2/5. But then we're having coffee. So that's going to be 1/5. Sorry, I'm just cheating by looking at my notes. And then we're going to go 2/5 again. So 2 times 1 times 2 is 4, and then it's going to be over 125. All right, and then the probability of coffee tea, CTT, we've got 3/5 times 2/5 times 4/5. Okay, so 3 times 2 times 4, so that's 24, and then the denominator is still 125. Now, your whole probability, we just add all these up. So it's going to be 8 plus 4 plus 24 over 125. All right, so what's that? 36 over 125. All right, so that was worth 3 marks, probably more than what you would get on an actual exam, maybe. Okay, so a method mark for identifying what you need. So sorry, I should go back. Identifying the teas and coffees, and answer mark for doing your fractions, and then your final answer. All right, moving on to question 6. All right, show that the composite function f of g of x is defined. All right, so for it to be defined, we need to have a look at the domain and range of both of the functions. So for g of x, and then what have we got? F of x. And I might just do domain here and the range. I feel a sneeze coming on. All right, so they haven't stated the domain, so we've got to do that on our own. So for square root of x plus 2, that's any real positive value or 0 to infinity. Sorry, including 0. So I'm going to just do 0 to infinity. And the range, the domain for e to the power of x plus 10 is going to be from 10 to infinity. All right, then the range. So this is why it's good to know what these graphs look like. So we've got a square root graph. So that's going to go from, sorry, I just realized that this should be a -2, and that's going to frustrate me because I'm going to have to undo till we get, can undo for me? Good. All right. I was thinking too much of what the graph looked like without actually doing the translation. So obviously it's shifted to the left too, but you can't take the square root of a negative number and get a real value. So we should have actually had -2 here to infinity. Whoops. And domain of f of x. So we're going from 10. Actually, no, I'm doing the range. Oh my gosh, not concentrating. That's going to be the range. I'm thinking of the graph shifting up. There we go. And that's really all we need for this question, but I'm going to keep going with the other two, the domain and range of the others. Okay, so for this one, e to the power of x, it can be any real value. So don't have the space to write it, so I'm going to just write it there. And the range of the square root graph, it's going to be anything positive, including 0. So we'll just go from 0 to infinity. All right. So show that the composite function is defined. So for it to be defined, the range has to be a subset. So I'm just, instead of writing has to be a subset, I'm just going to use the subset sign of the domain of g of x. Oh, sorry. Oh my gosh. Sorry about that. It should be the other way around. The range of f of x. It's a subset. It's getting late. I shouldn't be doing this late at night. The domain of g of x. All right, so g of x should fit into, that's basically saying the domain of g of x, sorry, the range of f of x should fit into the domain of g of x. So the range of f of x, so 10 to infinity, has to be a subset of -2 to infinity. All right, so that's all we need to do. All right, we've showed that, we've identified the range of f of x and we've identified the domain of g of x. So that's all you need to do for this one. And what it means by a subset, sorry, I'm going on, but we don't need to do this in the exam. There's -2. All right, so if I was to draw the domain of g of x on a number line, there it is, keeps going until infinity. And then if I was to write the range, so let's put 10 up here. All right, so subset just means it's included. If it was below -2, so let's say it was -10 to infinity, then it wouldn't be a subset because it would be outside of the domain of g of x. All right, question B is a bit easier to explain. All right, I might have to pause this. Oh my gosh, I'm not focusing too well. So composite functions just mean we're going to substitute g of x into f of x. So I'm going to call that h of x just to make it a bit easier. All right, so f of x is the square root of x plus 2. So instead of writing x, I'm going to write e to the x plus 10. And then we're going to put the plus 2 on the end. So it's just substituting it in. And then we need to add 10 and 2 together. So we get 12, and I'm going to put that square root sign. With your square root sign, it must go over everything that it's taking the square root of. If you just do a sloppy thing like this, all right, it looks like you're only taking the square root of e to the power of x, or even if it was a little bit longer like that. It needs to go over everything. So don't be sloppy with your work. All right, moving on to question C. Solve the equation f of g of x equals e to the power of x. Okay, so I'm going to write that again. E to the power of x plus 12 equals e to the power of x. And now remember at the start, I said this looks like it's going to turn into a quadratic, and it is, because when I'm solving, I need to get rid of that square root sign by squaring both sides. So squaring e to the power of x gives me e to the 2x. And I'm going to bring everything over to the one side. So e to the 2x minus e to the x minus 12 equals 0. Now we let k, or any other letter you like, equal e to the power of x. Probably not e or x or any letter that you're using. All right, then we've got k squared minus k minus 12 equals 0. So we want to just factorize this. So two numbers that multiply to give you negative 12 and add to give you negative 1, the coefficient of k. So that's going to be negative 4 and positive 3. Now solving that, we get k equals 4 and k equals negative 3. These do appear on VCAR questions. I did one just earlier today. All right, so we let k equal e to the power of x, so obviously we need to substitute that in. What do we got? Negative 3. Now, e to the power of x cannot equal a negative number, so we're like, doop. All right, so that means x is equal to, when I get e by itself, I'm going to take log of both sides. Sorry, not e by itself, x by itself. I need to take log base e to both sides. So your answer is log base e4. All right, question 7. So here we're going to be using our log laws again. So we can only use our log laws when we've got the same base. So you can see we've got the same base there. And because you're subtracting your arguments, so what's in the brackets is just divided. So it's going to be 6x over x plus 1 is equal to, and I'm just going to move that to be the power. All right, so that means we can now get rid of our logs and just play around with a little bit of algebra. All right, so x squared times x is x cubed, x squared times 1 is x squared. Let's just bring everything over to the same side. Okay, so we're going to take out x as a common factor. And then we're going to factorize that bracket. So two numbers that multiply to give you negative 6 and add to give you 1. So it's going to be negative 2 and 3. Okay, so we're going to say, all right, x equals 0, x equals 2, and x equals negative 3. Now, whenever you have solutions, you do need to check what is valid. So if we go back up, let me scroll up, computer. Okay, so we can't have an argument. So what is inside the bracket? It can't be negative. So if I substitute in negative 3, okay, that's not going to work. All right, because it's going to give me a log of a negative number, which we can't do. All right, substituting in 2, I'm going to have 6 times 2 is fine. 2 plus 1 is fine, and 2 is fine, so that's good. And then substituting in 0. So we also can't have 0. So we can't have x equals 0 either. So our only possible solution is x equals 2. All right, moving along. Might just go up here. I just the assessor, I'm just reading the notes. So even if you did get those 3 solutions, the assessor said you didn't realize that the only possible solution was x equals 2. So that was worth 3 marks. So probably getting to that, having those 3 solutions would give you the 2 marks. But you've always got to check your logs. Okay, so always go back, or any answer, go back and check the relevance of it, especially with logs. All right, question number 8. All right, so we're going to find the derivative of 2x plus 1 times sine x. All right, so for this one, we're going to use the product rule. So we let u equal 2x plus 1 and v equals sine x. Now, your product rule is on your formula sheet, and I do actually know the product rule, so I don't need to refer to it. And the derivative of sine is also on your formula sheet, so it's cos. But let's just double check, because one is always negative, one is negative, and I always get them mixed up. All right, so good. Okay, so our derivative, we're going to multiply u times dv dx, so 2x plus 1 times cos plus v sine x. Oh, I'm running out of room. Oh, good. Times 2. Okay, so that's going to be 2x plus 1 cos x. I kind of feel like I could have just left it at that previous line. All right, there we go. I'm just going to double check my answer. Cool. All right, hence find the antiderivative of x cos x. So what we're doing here is we're going to use our knowledge of the previous question to solve this one. All right, so we basically want to use our knowledge from the previous question to get this. So the antiderivative of our derivative, so I'm going to write our antiderivative first. So we've got 2x plus 1 times cos x plus 2 sine x. And remember, if you're doing an integral, you need to write dx on the end, is equal to our original. So what was that? 2x plus 1 times sine x. So basically on the left-hand side, I want to get this. At this point, it's not like that. So I can see I've got a cos here, but I don't have an x, cos x, but I can expand this bracket. So multiply the cos x by the 2x and the 1. So 2x times cos x, so 2 cos x. And then we've got plus cos x plus 2 sine x dx. Now I'm not going to do anything with the right-hand side just yet, but I'm still going to write it down because I will be doing stuff to it. All right, now I can see I've got an x cos x here in my first term, but I need to take that 2 out to make it x cos x. Now I'm going to leave it as its own integral. Okay, but that means that I need to do everything else as their own integral as well. Ooh. 2 sine x dx equals 2x plus 1 sine x. Oh, this is annoying writing the whole thing over and over again. You could probably find some shortcuts. Okay, so I'm going to go ahead and just do the definite integral of these next two. So I'm going to leave the first one there. Okay, because remember, that's what we want, except for that 2, but we can deal with that 2 later. All right, so the antiderivative of cos x is on our formula sheet. I'm pretty sure it's sine. Okay, it is. Good. So sine x. And then the antiderivative of 2 sine x is going to be minus 2 cos x. All right, so I want to have just this left on the left-hand side, so I'm going to take everything else over to the other side. So 2x cos x dx is equal to 2x plus 1 sine x minus sine x plus 2 cos x. The last thing I need to do is get rid of this 2 out the front, so I've got to divide everything by 2. Okay, so we're going to have, let's put a half out the front. Actually, I wonder if I could just leave it with a half there. No. Just seeing what the answer was. And then a half times 2, they cancel each other out, which is fine. Now, looking at that, we can't really simplify it anymore. We could probably take half out as a common factor. I'm just seeing what it's making me do that. Sorry, I'm just looking at the answer. All right, I'm not going to write the left-hand side anymore. So I will take out, just trying to have a quick look. Maybe we'll do the 2x plus 1 on 2 sine x minus a half sine x plus cos x. And then we can bring these two together. So we're going to have 2x plus 1 over 2 minus a half sine x. Oh my gosh, plus cos x. All right, because their denominators, the denominators are the same, we can do 2x plus 1 minus 1 over 2 sine x plus cos x. Nearly there. So they cancel out and those 2's cancel out. So we're left with x equals sine x plus cos x. Now, when I was looking at my answers before, it did have plus c. So because it doesn't say find a antiderivative and it hasn't given us any more information, as soon as I started taking the derivatives, I should have put plus c on there. So where did I do that? Here. So I should have my plus c. All right, but I'm just going to put it on the end. Oh my God, what an effort. So that was integration by recognition. It's a pretty tricky one compared to others that have been on the VCAR exams. But I think the method that was used, you need to be familiar with that. I think the simplifying was a bit problematic, and it being only worth 2 marks is a bit frustrating. I would probably allocate 3 marks for that one. All right, moving on to question 9. Is that going to be our last one? I think so. Okay. But it's a long question. Okay, so question 9. The graph of the function f of x is shown below. This graph has a maximum at the point. Actually, girls, I am just very conscious of the time, and I'm going to be having to get off anyway in 5 minutes. So I might leave question 9 for now and do a separate video on it. It is probably also going to be one of the more challenging questions, so I can see it taking probably longer than what I would like. All right, so I'll pause. I'll stop here and do a separate video for question 9. Bye.